Hi, today we're going to be talking about section 1.6, solving compound and absolute value inequalities. With the inequalities, we're going to be solving an and equality or inequality. That's where you basically stay between all the numbers between 2 points. And then we're going to be talking about or compound, where you do all the numbers except for some from one point to the other. It'll make more sense when we show it as a graph. We're going to be solving absolute value inequalities and multi-step absolute value inequalities, and then we're going to also write and solve absolute value inequalities based on word problems. Okay, to start off, you need to think about what is an and compound inequality. So if you look in this example here, it's where you're confined on multiple sides, so it's almost like you have two separate equations or inequalities. One says negative 12 is less than or equal to 4x plus 8, and the other end says 4x plus 8 is less than or equal to 32. Okay? When it's an and one, we'll get a solution. We'll get two numbers for a solution, and it'll fit inside this. I don't know what the solution is, but let's say it was like negative 1 is less than or equal to, that's a negative 1. X is less than 3, something like that. Well, I guess in this case it would be written like that. Then you'd go onto your number line, you'd go negative 1, you'd go 3, you'd have a filled in dot there and a filled in dot there, and it's everything in between those two lines. So that's how you'd fill it in if we got that for our solution. It would mean that all values that work are the ones that are between negative 1 and 3, including the negative 1 and the 3. So how to solve these? You can split it up like I read it, to where you do two sides. So you could just do the left side, this part, so you could solve that, and then you could do the right side and solve that, and then put them back together. I think it's faster and easier if you just solve both at one time. So the goal is we need to get x by itself, just like any time we're solving for x. So we've got this 4x plus 8, so we need to get rid of the addition first. So we get rid of adding 8 by subtracting 8, but we have to do it to all three of these. Okay, so negative 12 minus 8 is negative 20, is less than or equal to 4x. We don't have the 8 anymore because it just canceled. Is less than or equal to 24. Okay, now how do I get rid of that 4? Well, it's multiplying. The inverse of multiplication is division. So I divide everything by 4. So that gives me negative 5 is less than or equal to x is less than or equal to 6. So on my number line, I'd go from negative 5 up to 6. Okay, and it's going to be filled in because it says x. This says negative 5 is less than or equal to x, and it says x is less than or equal to 6. So that's our bounded region there. Okay, go ahead and hit pause and give this a shot yourself with the next one. Go. Alright, hopefully you added 2, added 2, added 2. So we get negative 3 is greater than or equal to 3z, which is greater than negative 12, and then divided by 3, divided by 3, divided by 3. So you get negative 1 is greater than or equal to z, which is greater than negative 4. Okay, and then I can also rewrite that so that it makes sense to me. Well, it doesn't matter. We'll just go on our number line here and take a look. So we have negative 4 up to negative 1. Okay, so negative 1 is greater than or equal to z. So that would be from this point. It says that negative 1 is greater than z, so z has to be less than or equal to, so it would be this way. Okay, and then it says z is greater than negative 4, so that would be this way until those two meet there. So this is an or compounded inequality, where we have 5j is greater than 15, or negative 3j is greater than or equal to 21. So when we solve these, we're going to see that it's going to kind of it's going to include all numbers except for a certain area. So let's just go ahead and solve both of these so we can see what the solution looks like and see how we would graph that. So the first part, I'm going to kind of move this to the side a little so that we can see it better, or I can see it better. So I'm going to divide both sides by 5. Okay, so I get j is greater than or equal to 15 divided by 5 is 3. And on this side, I'm going to divide by negative 3, divide by negative 3. We learned if we divide by negative 3, the sign changes, so that's j is less than or equal to 7. So now my solution says, so if I go to my line, I'm going to have to draw a 3 and a 7. So it says, if we drew the first part, j is greater than, fill in that dot, or equal to. We go this way, j is less than, so this one's no different than the one before. I know I said I want you to try this one, but I want to try this one just to make sure that we get one that has the other example where the lines actually go away from the points. So let me do this one for you too. So here, this first part, I would add 6. I would add 6, so I get g is greater than negative 5. Over here, I would subtract 4, so I have 2g is less than negative 19. Divide by 2, divide by 2. G is greater than negative 9.5. So let's see. I have g is greater than negative 5 and g is less than negative 9.5. So if I draw that, here's my negative 9.5. Here's my negative 5. G is less than 9.5, so it's an open circle and we'd go left. And G is greater than negative 5, so I would go to the right. So notice how that one, it goes forever to the left and forever to the right, and what we don't include is the middle. So that's usually when you see is solve an or compound inequality. A lot of times they'll have this as the solution, where you have kind of a hole in the middle of all solutions. Next, solve absolute value inequalities. So if we have an absolute value, if we think about this, the absolute value of x has to be less than 6. So 6 does not work because that's equal to 6. 5 works, 4 works because those are all less than. As we go into the negatives, those all work until we get back to 6 again. Once we get to 6 and bigger, like if it said negative 7, is negative 7, the absolute value of negative 7, well that's 7, is less than, so 7 is not less than 6, so that wouldn't work. So basically we know what this is really saying is that it's negative 6 is less than x is less than 6. And as far as a number line goes, that would look like from negative 6 to 6. We would have this solution in between those numbers there. Okay, so that's the graph. Absolute value of x is less than 6. Okay, you go ahead and try it with the absolute value of t is greater than 3. Hit pause. Okay, absolute value of t is greater than 3 would mean that if we think about this, what numbers work? Well, 4 works, 5 works, 6 works, all the way up to infinity. And as we get down, like negative 4 works, negative 5 works, negative 6 works, and so on. So you might see it written like this. Negative 3 is greater than t, is greater than 3. So if we drew a number line there, we'd go negative 3, 3. Okay, we'd have our open circle and we shade it to the left because it says negative 3 is greater than t, or another way to say that is t is less than negative 3. And over here, t is greater than 3 would be this direction there. So there's another solution for you. Okay, solving a multi-step inequality. So the best way to think about this would be to, remember we do the plus or minus to get rid of the absolute value, so we do plus or minus. That or is just set up an or statement, so you could write that as two inequalities, like 4x minus 7 is greater than 13, or 4x minus 7 is greater, sorry, not greater, but less than 13, because if you think about that, it's all numbers. If we go to the other side of the absolute value, it has to be less than a negative 13 there. So there's our other part, because being less than would kind of be, if we take the absolute values of numbers that are less than negative 13, we get the correct solution. So just basically when you do the or, you have to flip the sign and put that negative on there. So it's kind of like multiplying both sides by a negative that flips the absolute value sign. Okay, so we should add 7, 4x is greater than 20. Divide by 4, x is greater than 5. On this side, same thing, add 7, 4x is less than, what would that be, negative 6. Divide by 4, x is less than negative 3 over 2, or 1.5. Okay, to graph that solution, we have negative 3 over 2 and 5. X is less than, be an open circle in this way. X is greater than 5 would be that way, so that's our solution to that one. Okay, hit pause and you try the next one. Okay, so hopefully first thing you did was kind of split it into two and said, okay, we can have a plus or minus here and a plus or minus here. So we have 5z plus 2 is less than 17. Or we can say 5z plus 2 is greater than negative 17. Okay, when you solve these, subtract 2, 5z is less than 15, so z is less than 3. Subtract 2, 5z is greater than negative 19. Divide by 5, z is greater than negative 19 fifths. Okay, come over here, we would say negative 19 over 5. From here we have 3. So z is greater than negative 19 fifths. That would be this direction. And it's less than 3, so it's everything in between those 2 points there. So hopefully that's what you got. Okay, time to try to put a word problem to this. So you go ahead and hit pause here. I'll read it. You hit pause. Try to come up with an absolute value that represents the inequality, and then solve it and graph the solution. Rachel is considering colleges to attend and determines that an average tuition among her choices is $37.25 per year, but the tuition at her school could differ by as much as $1,650 from the average. Write and solve an absolute value inequality. So go ahead and hit pause, give that a shot, see what you come up with. Okay, well, if you know that whatever the college tuition is, if we called it X, okay, if we call that tuition X, if we subtract the $37.25, the average amount, okay, the absolute value of that should be less than, it says as much as, so maybe we're equal to $16.50. So that's the absolute value, because if we don't really, it's both. It could be bigger where it's above, or it could be smaller where it's below, but it needs to be, no, the difference can't be any more than the $16.50. So hopefully that's what you set up. If you're trying to solve this, remember we'd do plus or minus to both sides, so we'd get X minus 37.25 is less than or equal to 16.50. And we would get X minus 37.25 is greater than or equal to negative 16.50. So if we added 37.25 to both sides, did the same thing over on this side, we would get X is less than or equal to, let's see, I'd get 75, there'd be a 3, 4, 5. So X is less than or equal to 53.75. And on the other one, if I subtracted those, let's see, what would I get? X is greater than or equal to 2,075. Yes, 2,075. Okay, so that would be your range. So if you're graphing that, you would be looking between colleges that are 2,075 a semester and up to 53.75, and we would enclose those circles and go everything in between. Okay, so hopefully that wasn't too bad for you. Bring in any questions. Thanks.